The longest any spacecraft has ever survived on the surface of Venus is 127 minutes. That record has stood since 1982 because Venus does not permit longer visits. It destroys everything we send.
Venus is our nearest planetary neighbor. On certain nights, it is the brightest object in the sky after the Sun and Moon. It has roughly the same size, mass, and gravity as Earth. For centuries, we called it our twin, but it's better thought of as our evil twin.
So, three numbers define the evil twin's surface. 464 degrees Celsius, hot enough to melt lead. 92 times the atmospheric pressure of Earth, equivalent to diving 900 meters beneath the ocean. And everywhere, clouds of concentrated sulfuric acid.
The carbon dioxide atmosphere of Venus is so thick and so compressed near the surface that it crosses into something called a supercritical fluid, a state of matter that behaves like both a gas and a liquid simultaneously. You cannot breathe it in or swim through it. It simply crushes and dissolves whatever enters it.
The planet's cloud deck, stretching from about 48 to 68 kilometers altitude, is composed largely of sulfuric acid droplets at concentrations of 75 to 96%. These clouds are permanent, global, and impenetrable to visible light. From orbit, Venus appears featureless, a perfect, blinding sphere that hides everything within it. Before the space age, serious scientists imagined Venus might be a warm ocean world beneath those clouds, perhaps even inhabited. Then, in 1962, NASA's Mariner 2 flew past and measured the surface temperature from space. The number that came back, around 500 degrees Celsius, quietly ended the dream of a neighboring civilization. The Soviets decided to go anyway. Through the 1960s and 70s, the Soviet space program sent probe after probe to Venus, a campaign so ambitious, so relentless, and so costly that it has no real parallel in the history of planetary exploration. They called them the Venera probes. Most failed, but some succeeded spectacularly. In December 1970, Venera 7 became the first spacecraft to transmit data from the surface of another planet. Its parachute partially failed. It hit hard. It tumbled. But for 23 minutes, lying on its side in the Venusian heat, it whispered temperature readings back to Earth. That was the beginning.
The pinnacle came on March 1, 1982. Venera 13 landed, deployed its cameras, analyzed the soil with X-ray fluorescence, and transmitted the first color photographs ever taken on another planet's surface. The spacecraft had been designed to survive 30 minutes. It lasted 127. This record has never been broken. Here is the part that surprises most people. Venus is not hard to reach. In terms of orbital mechanics, the delta V, the fuel required, the travel time, Venus is actually easier to get to than Mars. Launch windows come around every 19 months, compared to 26 for Mars. The trip takes roughly half as long. The difficulty is not the journey, it's the destination. Everything we know how to build, electronics, batteries, solar panels, lubricants, polymers, seals, has a temperature range it operates within. Standard silicon electronics fail above 125 degrees Celsius. Venus's surface runs at 464. The gap between those two numbers is where spacecraft go to die. There's another problem. Earth is wrapped in a powerful magnetic field generated by its churning iron core. Venus has almost none. Venus rotates so slowly, one Venusian day is longer than an entire Venusian year, that its core barely stirs. Without that field, the solar wind strips away the upper atmosphere and bathes the planet in charged particles. You might think solar power could help, but the same clouds that make Venus brilliant from a distance block roughly 80% of incoming sunlight. What reaches the surface is a dim orange glow, enough to see by, but nowhere near enough to run a solar panel.
and nuclear power sources cannot reject their waste heat into an environment already hotter than they are.
Consider the contrast. NASA's Opportunity rover operated on Mars for 15 years. Curiosity is still driving today. Their electronics are standard. Their solar panels work fine. Their seals don't dissolve. On Venus, every single one of those assumptions collapses simultaneously. It is not one engineering problem. It is all of them. And they start right from the moment of touchdown. NASA's answer is called Da Vinci. Scheduled to launch in December 2030, it carries a descent sphere roughly 1 meter across, built, in the words of the mission team, like a submarine. Titanium walls, phase change insulation, a sapphire window for the camera, because sapphire doesn't melt. It is designed not to survive Venus indefinitely, but to last just long enough.
Da Vinci won't land gently. It will fall for 63 minutes through the Venusian atmosphere, measuring noble gases, isotope ratios, and trace chemistry no probe has sampled in over 40 years, since the Pioneer Venus probes in 1978. If it survives touchdown, it may transmit for perhaps 20 minutes more. Every second of data will be earned.
What Da Vinci is really asking is one of the deepest questions in planetary science. Was Venus once habitable? The planet's noble gas ratios, inert elements that don't react with the environment, can tell us whether Venus began with water and when it lost it. Whether our twin had a different childhood than its present horror suggests.
Meanwhile, a second NASA mission, called Veritas, a radar orbiter, aims to produce the first high-resolution map of Venus's surface. Magellan mapped the planet in the early 1990s at roughly 100-meter resolution. Veritas would achieve 30 meters, and more importantly, could detect millimeter-scale surface deformation, the fingerprint of active volcanoes, shifting crust, a geologically living world. Europe is sending its own orbiter. ESA's Envision, launching in November 2031, will carry the first subsurface radar sounder ever aimed at Venus, an instrument that can peer 1 kilometer beneath the surface without landing. It will also carry spectrometers tuned to the handful of narrow atmospheric windows where Venus's clouds briefly become transparent to infrared light, enough to read the rock below. 3 missions, 3 space agencies, all launching within months of each other in the early 2030s. Scientists are calling this the Decade of Venus, a convergence that hasn't happened since the Venera program wound down. And unlike the Cold War race that drove that program, this one is driven purely by the questions Venus keeps refusing to answer.
There is one place on Venus that is, strangely, almost hospitable. At an altitude of around 50 kilometers, the atmosphere thins to roughly Earth's sea level pressure, about 1 atmosphere. The temperature drops to 30 to 75 degrees Celsius. Warm, but survivable. The gravity is 0.9 times Earth's. There is more sunlight available there than at Earth's surface. It is the most Earth-like environment anywhere in the solar system, outside of Earth itself. NASA's Langley Research Center ran a study exploring what it would take to put an airship in that cloud layer. They called it HAVOC, the High-Altitude Venus Operational Concept. A hydrogen-filled airship, solar-paneled, 129 meters long, floating above the acid. The engineers concluded it was technically feasible. The sulfuric acid at that altitude is dilute enough that Teflon-coated materials survive it. And in a sense, it has already been done. Once, briefly, by the Soviets. In 1985, the Vega 1 and Vega 2 missions each dropped a balloon into the Venetian atmosphere. Those balloons floated for 46 hours each, drifting 11,000 kilometers on winds that travel faster than a commercial aircraft. For 2 days, humanity had eyes inside the clouds of Venus.
Current models suggest Venus may have had liquid water on its surface for as long as 700 million years ago. Venus was not always hell. Something happened to it. Understanding what may tell us something important about what could happen right here on Earth.
Venus and Earth formed from the same raw material, in the same neighborhood of the solar system at roughly the same time. One became a world with oceans, a magnetic field, plate tectonics, and life. The other became a furnace. The gap between them is not a curiosity, it is the central question in planetary science. Why did one world thrive and one world cook?
There may be a path to longer surface survival. Engineers at NASA Glenn Research Center have been testing silicon carbide electronics, a semiconductor that operates reliably at 500 degrees Celsius. In lab tests, circuits built from it ran continuously for more than 60 days under Venus-like conditions. If those circuits can be made into real instruments, the 127-minute record could one day be measured in months. The last image Venera 13 ever transmitted shows a flat, orange-gray surface strewn with flat rocks under a dim, rust-colored sky. It is one of the most alien photographs ever taken, a world that looks almost geological, almost familiar, until you remember what is happening just outside the camera's frame. The crushing pressure, the heat, the slow obliteration of the very machine taking the picture. Venus asks something unusual of us. Not just better rockets or longer battery life. It asks us to build machines that can think and observe and transmit in conditions we have never been able to sustain. It asks us to engineer for a world that wants, in every physical sense, to end our instruments. And the fact that we keep trying, that we are sending 3 new missions in the same decade, suggests we think the answers are worth it. There is something quietly moving about that persistence. A planet that has defeated every lander ever sent to its surface, that has held the same 127-minute record for over 40 years, is about to receive, within the span of a few years, more scientific attention than it has seen in a generation. Not because it is welcoming, but because it is not.